Hello everyone. Alright, let's have a look at electrostatics and another example of how they can actually combine. Now what we've learned already with vectors, with Newton's law, and we're going to look at the next question. So let's start. Okay, the question says, a ball carries a charge, and the moment you see that charge word, you know immediately you've got to do with Coulomb's law. And what is the formula for Coulomb's law? Let's just write it here. It is that the force that exists between any two charges equals K, the constant, charge 1 times charge 2 divided by the distance between those two charges squared. Alright, so that is my formula that I'm going to use. Now let's see what the question is. Okay, so they do give me the following diagram. Okay, so I've got a rope coming down. Now a rope already suggests to me vectors. Okay, so that's a rope. On that rope at the bottom is a charge suspended. And they do give me this value of the charge as 0.6 micro Coulomb. Alright, there's my first catch. It's suspended from a ceiling in an elastic thread and as shown below. Another ball, so this is ball X. Then another ball Y is on an isolated stand over here. So this ball cannot move. It's fixed and it's isolated. And that's got a charge of -1 microcoulomb. So that is a plus, a positive force, a negative force. And immediately I realize why that rope is now going sideways. It's pulled sideways because if that is a plus and a negative force, we know they're going to attract each other. But Y cannot move, so it's going to pull X towards it. And that pull is going to go and extend, and that whole system, that pull is really going to just stand still like that. So it's being pulled sideways and there it hangs still. And they do give me here the angle, let's just see. Oh yeah, they also give me here that Y and X is brought to a distance of 18 centimeters apart. Now 18 centimeters already, also my alarm bells goes off. So let's work that out. 18 centimeters divided by 100 to take centimeters to meters. And I'm going to write already here 1,8 meter. Okay. So don't, just be very careful as you read, already be very alert. Okay. Then ball moves, X moves towards ball Y due to electrostatic attraction. So it suspends at an angle of 7 degrees. So I do get that angle there as 7 degrees vertical, and then it remains in equilibrium. So the whole thing stands still. Now, I hope you see what I'm seeing. Remember, with electrostatics, it's a force. And a force is a vector. Now the moment I see a rope, and I know that charge has got a weight as well, what is that? The gravitational force on X. I see X is being pulled to the side. Immediately I start saying to myself, listen, there is 3 forces working here. Where's those 3 forces? There's a force working on X because of the weight of that little ball downwards. So that is my weight, or Fg, gravitational force. There's another force which I now know because we just did electrostatics, which is that X is being pulled in towards the right by Y. So that is a force of Y onto X, or F, electrostatical force. And where's the third one? There's a third one in the rope, so T for tension in the cable, that works upwards. Okay, so now I've done a rough sketch like this. So now I'm going to go to the questions. Here comes the first one. State Coulomb's law. What have I told you guys? You better know these laws out by heart, exactly as it stands in your books that you learn it from. All right. So up to the next question. Draw a labeled free body diagram showing all the forces acting on X. Okay, perfect. That's what I just did. Now I'm just going to not do it on here. There I was just going to do it roughly, but I'm now going to copy it over into my books. And remember, I always have to show one angle. So I'm going to show that 7 degrees up there, and I'm going to just have these 3 forces, and you have to have an arrow, and you have to say what is the force. Okay, to get your 3 marks. Now, whenever they ask me a free body diagram, guys, you know what? I want to just give you a tip. Look at the amount of the marks that you're going to get. And that's always an indication of how many forces there is. You know, so let's say, So let's say the marks you're given is 3. I can check myself. 1, 2, 3. Perfect. I've got them all. Okay. Next question. Calculate the magnitude of the tension in the string. Oh, that's my dog again, snoring away here. Calculate the magnitude. So we're basically going to have to calculate T. Now first, of course, I'm going to look at, which force do I have? What do I have? Now I see, of course, there's the electrostatic force, and they do give me Q, Q, and R. So I immediately realize I can work out that force. That's not asked, okay? So if I'm going to look at this free body force diagram, I'm going to immediately realize what am I going to have to draw for myself to determine tension. I'm going to say, okay, let's do a vector diagram, because it's 3 forces. I know it's going to create a what? A closed body diagram. So I'm going to get a triangle. So let's start with the first one. So there is my gravitational force or my weight. Then I'm going to add onto that one, head to tail, I'm going to add my F, electrostatical force of Y on X. And then I'm going to add to that my closed body diagram. So that would be T. Now where is my 7-degree angle? That is where T comes towards a vertical line. So there's my arrow for T. There's my vertical line. Okay, perfect. So that angle is 7 degrees. And the moment I've got my vector diagram, now I can start to go to work. So again, I'm going to first then work out this electrostatical force. Why? Because that's the only thing I've got to work with. I don't have the weight, I don't have the mass. If they would have given me the mass of this charge, I could have worked with that and then say, okay, I've got Fg or my gravitational force, so I've got that one. But I don't. They don't give me any weight or mass for that charge. So the only one I can go with, and of course that was also the electrostatical question. So let's start. So K equals, and there's my formula, 9 times 10 to the 9. And you know what I was just thinking about? They always give you a clue which formula to use, because what have they asked me in question 7.1? They said to me, ask me, state Coulomb's law. You know, that's a giveaway. If they ask you that question in the first question, it's to remind you, you know, it's an electrostatic question, go to Coulomb's law, what is the formula of Coulomb's law? And that is that one. Okay, so don't get confused with your formulas. All right, and then they did give me that as a micro Coulomb. What do we do with a micro? So we know milli, micro, nano, pico, minus 3, minus 6. Okay, great. So it's minus 6. So it's 0.6 times minus 6 Coulomb. Okay, This one is -1. I'm not going to have the minus in there. I'm just going to say 1 times 10 to the -6. Remember, we're not going to have any signs in there. And then I do have my distance between them as 0,18 square. And now I'm just going to quickly calculate that. So 9 times 10 to the 9, 0.6 times 10 to the -6 times 1 times -6 divided by the distance, 0.18 square, and I get my answer, Coco, 1,1666 Newton. Alright, so I do have then this one. So if I have that force there, and I've got an angle, and I've got a 90-degree angle there, now I can immediately start to work and use my mathematics. So because this is the opposite from the angle, I'm going to start with sin theta equals, what is the opposite? If y on x, electrostatic force, that one, divided by tension, but I need to work out the tension, so tension is going to be that F divided by sin, and my angle is 7 degrees. F I've just worked out already, so it's 0,1666 repetitive over sin 7 degrees. And let's get that quickly. It's still my calculator with all the decimals, fantastic. So I'm just going to say divided by sin 7 degrees. And I get that my tension in my rope is 1,367. So I'm going to rather than say 1,37, round it off to 2 decimals. It's a force, so it's in Newton. So there I've got the tension in the cable. So although it is an electrostatic question, I did use my previous knowledge of when there's 3 forces acting on the same point and they are in equilibrium. And then I know I better draw for myself a vector diagram. From the vector diagram in my triangle, I'm going to apply my mathematics and I'm going to come to the answer that they've asked me. All right, now what the question now carries on with, and what they do now is they say, a third small ball is put here, also on an isolated stand, and that is Z. And that has also got a charge of a minus Coulomb. So they don't say the magnitude, they just say we're going to add another minus. Now remember, this was a minus charge, and that becomes now an extra minus charge. All right, and here comes the question. What effect will the charge on ball Z have on the angle of the inclination of X? Stay only increase, stay the same, or decrease. So what would you say? What's going to happen if they add here another negative charge? Means that together the negative charges is going to become bigger. So that force is going to increase, and if that electrostatic force increase on X here, the angle is going to increase. All right, so I'm just going to say increase. Then in the next question they ask me explain. All right, so what is the explanation? The moment that the charges, the negative charges on the right increases, the force pulling onto X increase, which is going to have the effect that it's going to, X is going to move more to the right, and my angle there is going to increase. Explain why balls A, Y, and Z, why are these 2 balls placed on an isolated stance? Okay, why can't I just put it on anything? What's the reason for that? what do we know about electrostatics? It's only got a force, electrostatic charge, because of electrons. And if I don't have an isolated or an insulated stand here, those electrons are just going to run down, straight down towards Earth, and the charge is going to go. So we can't give them any way to move through. So where could they move through? They could move through, let's say, metals. Metals is a wonderful conductor. So nothing that can conduct charges. So it's an insulated piece, it could be wood or whatever. So those electrons cannot move and lose the charge. Right, so that is the question. Not so difficult. I know grade 11s, if you just started with electrostatics, but you always have to think, how are they going to combine previous knowledge in certain questions? And the more you practice, the better you get. Believe in yourself, you can do this.